Before the workshop starts, we're going to show you how to navigate through the video. Below the YouTube video is the Show More button. Click the Show More button to reveal the index. You can skip to the point that you want in the video by clicking the blue time link.
Okay, so now what we're looking at here is, remember this morning we skipped through the syllabus and said what? Look, there was question mark, question mark, question mark, and then it was our expressions and so forth and etc. So now after doing this morning's, where is the junior cert syllabus? Well, look at what have we got here. Use tables, diagrams and graphs as tools for representing and analysing linear, quadratic and exponential patterns and relations. Develop and use their own generalising strategies and ideas and consider those of others. And present and interpret solutions explaining and justifying methods, inferences and reasonings. Okay, so that was part of what we did this morning obviously. And then finding formula. Find the underlying formula written in words for which the data is derived, only for linear relationships. Okay, now that's words only for ordinary level. Now you'll see in bold then it says find the underlying formula algebraically for which the data is derived for linear and quadratic relationships. That's for your higher level obviously. Okay. Now, examining linear relationships. Show that relationships have features that were represented in a variety of ways. So what ways did we look at this morning? Tables, graphs, symbols, words and so forth. So that's all those. Distinguish the features that are especially useful. And remember we looked at this morning. Sometimes the table is a little bit more help. Remember when we went here with our zero and when we were looking at our counting squares and so forth. Okay. Discuss the rate of change in the y-intercept. So where do we see them on a graph and where do we see them in a table? Decide if two linear relations have a common value. Well, we looked at that. Remember the point of intersection. Okay. And investigate relations of these two forms. Okay. Is everybody happy with that? And then explore graphs of motion. Make sense of quantitative graphs and draw conclusions from them. Make connections between the shape of a graph and the story of the phenomenon. And describe both quantity and change of quantity on a graph. Now that's what we're going to look at next. And what do you see then last of all? Now come in your expressions and your normal. Does that make sense? But we've built up to it rather than the other way around. Does that make sense? Is everybody happy with that? Okay. And if we've not just built up under algebra, what have you built up a huge amount as well? You have a huge amount of coordinate geometry as well built up with them. Does that make sense? Because you know more about your slope and your points of intersection and even your axes and all that kind of stuff. Okay. Now just to show you a few questions from the exams. Okay, so this one here, the first one. Sheila investigating a number of square grey tiles needed to make a patterns in a sequence. The first three patterns are shown below and the sequence continues in the same way. In each pattern, the tiles from a square and its two diagonals. There are no tiles in the white areas. So basically what do you see? You have your pattern and what do you reckon they're asked to do with it? Fill in their table and find a formula. Okay, and then once they've found their formula, using your formula otherwise, find the number of tiles in the 10th pattern. Okay, so can they do some work with their formula? And then Sheila has 399 tiles. What's the biggest pattern in the sequence that she can make? So obviously where are your patterns leading on to? Your patterns are leading on to your sequences and series. So you're back into using your sequences and series formula, but you'll have the background done beforehand. Does that make sense? Okay. And then find in terms of n a formula for the total number of tiles in the first n patterns. So again, another take on their what? A sum of sums, but that means they'll have to have a bit of their sequences and series done as well there. Okay. And the same idea there again. Okay. So basically that's all to do with what? Their early learning, but plus then leading into what? Helping them with their sequences and their series. That's ordinary level Leaving Cert. Okay, and another one here now again with ordinary level Leaving Cert. John has given two sunflower plants. One is 16 centimetres and the other is 24. John measures the height of each plant at the same time every day for a week. He notes that the 16 centimetre grows 4 centimetres each day, and the 24 centimetre 3.5 each day. So again, what are they asking you to do? Draw your table and write down your formulas, okay? Draw your graphs. And then from your graphs now, can we get pieces of information? Write down the point of intersection and explain what it means. Now, like this morning, 212, explain what it means. You know, sometimes people say to you, well, it's over 2 and up 12. That's not explaining what it means. And check your answer then using your formula. So they'll have got it from the graph, and then they're asked to check their answer using their formula. Okay? And then the point of intersection can be found by either reading from the graph or using algebra. What state one advantage of using algebra? You don't have to draw a graph. Anything else? Yeah, it's definitely more accurate, because why? If it happens to fall, if it's not a nice number on your graph, it's up to your eye to read it. Doesn't that make sense? Okay. Okay, John's model for the growth of plants might not be correct. State one limitation of the model that might be affect the point of intersection and its interpretation. And then a final question. Okay, this one is coming in at foundation level. Okay, so what are they given here? Now, see the way it's much clearer in terms of what? What are you trying to instill in them? A fixed charge and a further charge. So it's laid out better for them in terms of, right, what are you trying to get into their heads? That we have a constant change and we have a starting point. Do they know what these things are, and can we get these onto a graph? So they're asked to fill in their table, and again they're asked to do what? Draw their graph, but in fairness, what's there for them? Their axes are there for them and all, okay? And then what are they asked to do then? Two very normal questions based on the graph per se, and then write down a formula to represent the affair. Now that might seem like it's quite difficult, but remember, what are you getting lots of practice in with them? Starting values and this change. So if they know how to get this starting value and change, and look, state clearly the meaning of any letters you use. They're just use their own letters and see what happens. What's making that change happen all the time? Is it the days of the week? Is it whatever? And get their formula made up themselves, okay? So that's just a sample of some of the questions to show you where it's coming into the teaching, okay? And again, verifying use your formula for part E to verify your answers to part C and D. Again, seen as a work. After the first 15 kilometres, the rate goes up to 135 per kilometre. Give a reason that could justify this increase. Okay, so this morning was all about what? Creating our graphs. And there were a tool then, once we had them created, we got more information from them. So now we're going to look at the graphs and see can we make any uses from them. Okay, so where does this come into the thing? Well, we explained it a second ago. Explore graphs of motion, make sense of quantitative graphs and draw conclusions from them, make connections between the shape of the graph and the story of the phenomenon, and describe both quantity and change of quantity on a graph. So that's what we're going to be looking at now in that part of the syllabus. Okay, so students at this stage will have studied what? They'll have looked at graphing of coordinates, they'll know the concept of a slope of a line, and they'll have the concept of speed being equal to distance over time. Now, you have these people, are on page 14 of your book there, folks. Now, the idea is that they're all queuing up for the bus stop. And each person queuing up there represents a point on the graph. So just scribble down underneath the person what number you think they are in your book. So where do we put people, folks? So, Catty, why are you saying that?
Because she's the smallest and the youngest.
Exactly, smallest and the youngest. So where do we go next?
Brenda.
Brenda.
Brenda's 5, is she?
Okay. Now, with Brenda then, you can clearly see what about Brenda. If you have Brenda picked to be that, why is Brenda there, and what's with her, or what seems to be with her? The number 1, doesn't it?
Oh, in height. Yeah.
Yes, in what way? So what do we say about the 1 and the 5? How would we describe them in English? Same height, but age is different. So who would you put with Brenda to be the same height, but clearly different in age? Dennis, exactly. Where are you going to put Earl? 4. Who's next? Frida. Where does Frida have to go? 2, because obviously Alice is the same height as Earl, but obviously she is older. Is everybody happy with that? So it's just an activity of what? Don't jump into putting things on. You should look at the axes because they are of great importance. Okay? Okay, now another one for you to have a look at. Okay, so we have this man and he's in the bath. Okay, now, what are we going to look at here? You have 1, 2, 3, 4, 5, 6, 7 situations to fit to that graph. Okay, so you have 7 situations. The graph below shows the variation in depth of water as Archie takes his early morning bath. Match the different parts of the graphs to the statements shown. Okay, so let's have a look and see how we got on. What do you want to go for 1, Magella?
Hot and cold taps are turned on.
Okay, so hot and cold taps turned on, perfect. Okay, and John, have you a 2 for us?
F.
F, what's F? F is turns off hot tap. And Harry, have you a 3 for us?
He turns off the cold tap and gets undressed.
Okay, cold tap turned off and gets undressed. Is everybody happy enough with that? Because nothing is happening there, so he's turned off the cold tap and he's getting undressed. So he gets into the bath, and what has happened? The depth of water has gone up. And Joanne?
He relaxes for a while.
Yes, and compared to the rest, he seems to have relaxed for. Yeah, exactly. And Stephen?
Gets out of the bed. Okay, how do you know? The depth of water has come down.
The depth of water has come down. Now, as well, if we look across here, what has happened? Is it the same as 4 when he got in? Why not?
He's wet.
Exactly. When he gets out of the bath, he's clearly wet. So he takes some water with him. So the depth goes down. And then finally, you have an easy one then, Michael.
Gets down. Yes. Okay. Or sorry, what we haven't.
Garzari gets out, so pulls the plug, so all the water goes. Is everybody happy with that? So it's a nice to look at scenarios in terms of, and trying to, and it was lovely what Deirdre said, but because it's the next logical step, because what can a student actually do? It's a nice one even for differentiated learning, because what can a student actually do? You can actually fill all the steps from the story without ever really knowing what's going on mathematically. And you know, that's perfectly acceptable, because then they can build their what? They can build their knowledge as it's been explained from other students. Does that make sense? Okay. Now, so on your whiteboards, I started to walk to school at a steady pace and then realised that I left my books at home, so I hurried back to get them. Then my mother drove me to school so I wouldn't be late. Okay, so I started walking to school at a steady pace, then I left my books at home, so I hurried back to get them. Look now, explain it. My one is when I was in school myself, when I was drawing the graph. Your one is from a student nowadays. Why? What's the difference? I'm telling you, this one is from when I was in school, walking to school in the 70s. In the early 80s. This is a graph maybe of a student nowadays.
He rang his mother and said, he rang his mother.
Exactly. And how do you tell that from Magella's graph?
There's no time at home.
Exactly. What did you do? Quick text. Get history book. Get into car. I'll be back. Okay, and Mammy is at what? Mammy is at the gate, history book in the car, and they take off. Does that make sense? Whereas my one is what? You have to walk in, get the book yourself. Exactly. Organise Mammy and then get going. Is everybody happy with that? So it's just, neither is right or wrong, except you can do what with it? you're able to explain what's going on, okay?
Shouldn't the slope of the second one be much steeper than the slope of the first one?
Mammy they live in a housing estate. We have to be very strict now on our speed limits. So there's a 20 km in the housing estate.
You were really rushing.
But, so, no, in fairness, you could put it, but you don't want it going vertical to wider because then poor Mammy is doing dangerous things. But you could put it better in terms of, it does look like, you know, this one is, it's definitely better than that one though, you know what I mean?
Well, he hurried home, so therefore the one coming back is going to be a lot steeper than the one going up.
Yeah.
So that's fine. He spent a couple of minutes at home.
Yeah.
But the other one, the car one, generally should be a lot steeper. Well,
Than the first one.
If you live where I live, it'd probably be much, probably nearly flat.
If it was flat, that would mean it'd be going really, really slowly. Exactly, yeah. Exactly. Well, it depends on exactly where you live. But yeah, you could argue that it should be a lot steeper. Does that make sense? Because they're going in the car. Okay. Okay, another one. Do you remember the story of the hare and the tortoise? Use this graph to retell the story. So discuss this in your group. Okay. Who's going to describe this for me?
The blue line represents the hare. He takes off really fast, much faster than the red, which represents the turtle. Okay, you can see that from the slope.
Okay.
And then he has a rest. So he's at that position for quite a while. You see the flat line. And then he wakes up and he takes off again, very fast again. But the turtle has been going at a steady rate, gets to the finish line. He's waiting at the finish line, finished. That's why his position hasn't changed.
Perfect, okay. Okay, so another one I'm going to have you to do. Mary and John run against each other in a 200-metre race. Mary's time is 25 seconds and John's time is 40 seconds. Draw graphs to show their runs just using one set of scales and axes, assuming that they each ran at a steady speed throughout. Calculate the speeds of Mary and John. Okay, what units do you use? Whose graph has the bigger slope? Calculate the slopes. How did the graph show that Mary ran faster than John? So if we could get you to have a go at that, please. And let's have a look. Calculate the speeds of Mary and John. Well, how are we going to work these out? Distance over time. So what did you get then?
Mary's 200 over 25, which is 4 metres per second.
200 over 25, which is 4 metres per second. And in that you've also answered the other question.
Okay.
Starting on 5, starting on 8.
Yeah.
Sorry, yeah, sorry, 8.
And V of John then is what? 200 over, and that's 5 metres per second, or metres per second, depends on what way you are teaching them at that stage. Now, and if we look then, also as well we've put in the units, because why? It's metres divided by seconds, so that's why it's metres per second, or metres/seconds, depending on what way you're teaching at that time. Now, whose graph has the bigger slope? Mary. Everybody happy with that? Okay, Mary's is definitely the bigger slope. Now, calculate the slopes. Now, here's again, over 3 means what though? Each box is how many? 5. So 5, 10, 15. And then what did we say over 3? And then 1, 2, 3, 4, 5. And each box that way is what? 25. So what are you dividing into what? 15. And what? Hopefully that will give you what? That will give you your 8 over 3. For John, we got 5 for his slope. So the slope of John's worked out to be 5. And if we worked out the slope of Mary's more accurately, what would it be? It'd be 8. Okay. Now why, folks? Why is that? What did we say this morning? our slope was in terms of words? Exactly. For every increase in x's, what was the increase in y's? So what are we looking at here? For every increase per second, what was the increase in meters? Okay, which is basically what? Your meters per second. Does that make sense? For every increase in meters per second. So you're doing the same thing because look at, these are your y's and these are your x's. Okay, is everybody happy with that? Okay, so you're looking at the change in your x's over the change in your y's again. How did the graph show that Mary ran faster than John? Yeah, what about it? It's a steeper slope. Without ever doing any calculation, clearly there, what about it? Mary's has a steeper slope, and obviously what did we figure out from here? That the slopes have something got to do with the speeds. In actual fact, what are they? The slopes are the same as the speed. So that means then if we just look at the slopes, we can very clearly see that she went faster than John. Okay. Now, what I'm going to do is I'm going to give you out 3 sets of graphs, and they're colour-coded. Thanks, Milan. You're all right. And they're colour-coded on paper the same way as they are up there. Now, so you have a set between you, and what you're going to do is, see, can you match it with the actual story? Now, what do we mean by this? Well, if you look here, there's the first set. So you can clearly see there's an A, B, C, D, and E, and F. So if you put the graphs lined up, 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, and 1, 6, and underneath each of them, one of these things fits with it. Okay, does that make sense? So one of those things fits with it. Now, so back to what they mean. The first set, the green ones, are all to do with distance time graphs. The red ones are all graphs of various different scenarios. And finally, the blue ones are a selection of graphs where containers are being filled at a constant rate and the depth of water over time is being examined. Okay? So I'll leave it to your own devices to figure out what to do. So the first one, moving at a steady, constant pace. Okay, well that's 1D. Sorry, I'm going to go with the graphs. Moving fast, then slowing slightly, then getting faster again. Is everybody happy with that? Because look, you have it moving fast, then there's a part in the middle where it's slowing, and then getting faster again. Now 1, 2 will go with what? 1B, exactly. Moving fast pace, but then gradually slowing down to a slower pace. 1, 3 is going to go with what? Moving at slow pace and then rapidly increasing. Are we happy with that? Okay. 1A, happy with that? Moving at a steady, constant pace because it's all the same the whole way through. And then finally, what about this one? Now, would there be anything to distinguish between this and the other one?
Or fast.
Yeah, the fast is the only thing we have in this context because why?
It could apply to both.
Exactly. We could interchange those except for this one obviously must be faster than the other one because of the what? The slope. Okay? And then finally, moving at a steady pace and then stops for a period of time. Now that can be a difficult one for students because why? Stops for a period of time. Even though they've stopped, what continues? Time goes on. And then our next ones then, okay, what have we got here? So we'll start here with number 1. What's going to go with this lad? E. The graph shows the width of a square as the length of a square increases, because obviously why? The length and width of a square are the same all the time, okay? Now our next one then 2b. The graph shows the connection between the length and width of a rectangle of fixed area. Now why? Well, we looked at this with groups and we said, oh, fixed area. So Deirdre and Joanna were working with 6. So they had an area of 6. And then we looked at, well, how are we going to get this? What are our options to get an area of 6, looking at length by breadth? Well, 1 by 6. Okay, and then what do you notice about the length? As the length is going up, the breadth is going down. Okay, is everybody happy with that? And as well then, if you're bringing it on to another level, length multiplied by breadth, so what have we got then? That area over length equals B. So B is proportional to 1 over L. What type of graphs are they? They're a hyperbolic graph anyway. Does that make sense if you're bringing it to that level with them anyway? Okay. Now the next one, the graph shows the speed against time for a car travelling at constant speed. Now, another red herring, because why?
Speed and not.
It's speed and not distance. Okay, because remember, if it says the graph shows speed against time for a car travelling at constant speed. Now, if you're working out that there, what's the slope of that? The slope is 0, and what is it in a language terms? No.
Rate of change.
Yeah, but the rate of change of speed is what?
So,
Acceleration. Okay, and if you're, what does it tell you you're doing? Constant speed means there's no acceleration. Does that make sense? Okay, constant speed means there's no acceleration. Now the graph shows the area of a circle as the radius increases. Well, what type of an equation is that we've looked at today? It's a quadratic because it's simply pi r squared. Okay. Our next one then, this is your electrician, and very much like we were doing this morning, because what had it got? A starting value and a fixed rate of change. Okay. And then finally then, the population from 1954 increased slowly at first, but then increased more quickly. Okay. And as well, we were discussing, I wonder will we go for it here or here? And we were just discussing here. That's why in some of yours, I don't think the year was in on your ones, and I changed and put in a year to indicate that, look, there was some people initially. Okay. So let's have a look at these ones. Now, there's 2 different very distinct shapes in the graphs. What stands out in the graphs? Straight lines and curves. Can everybody see that? And then, now that you have them like that, which shapes gave you straight lines and which shapes gave you curves?
Ones that change like constantly instead of an immediate change.
Exactly. So, for example, give me an example of one of those types, Joanna.
Like F is one that changes constantly, and then 3D is one that immediately goes very small.
Exactly, because look at 3D, there's nothing, it's the same depth or the same thickness for a long time, and then it changes to a different one. Whereas in something like F, what about it? It's gradually changing all the way up along. Okay, so if we look at the first one, what are we looking out for in this? It has 3 different depths, clearly, but what about them? They change very sharply. So what's that going to be? D. Would everyone be happy with that? Okay. Now moving to the next one. It looks like we have the same type of curve, doesn't it? We have 3 different depths, but what about it? We have a kind of a smoothness going on, which is what one? Exactly, because why? What's this one now doing? Filling quite slowly, and it gets the thin part getting quicker, and then filling slowly again, okay? With no sharp changes, because why? It's all very gradual, okay? Our next one then, what's happening in the next graph? B, because why? We have 2 very distinct different areas filling at different rates. Now obviously what? Fast or slow? Very fast, the narrow piece at the bottom, and then it slows down for the wider part at the top. Okay, and next one, what about it? There's one rate of filling, but what about it? Not one rate, but what about the rate? It's changing constantly. Is everybody happy with that? It's changing constantly. Our next one then is our cylinder. Is everybody happy with that? Because why? It's the same shape throughout. And then finally, our cone. Is everybody happy with that? Because why? It's filling very slowly filling very fast at first and then getting slower, as opposed to which one? Very slow at first and getting faster. Now, the difference between those two graphs, graphically, students can have a big problem with. Do you know, what's this one that we say? Fast to slow. Whereas you can clearly see from the picture, it actually makes more sense for those, because they can clearly see that the cone is going to fill a lot faster at the bottom than it is at the top. Does that make sense? Whereas graphically, that can be harder for them to see. Okay? Okay, so that's today, folks. And I just want to show you a small little presentation now on the resources that are available for this strand and the other strands. Okay, so syllabus documentation, examination in 2012 only, and examination in 2013 for your junior certs. Now, it's important, obviously, that teachers would realise what, as soon as your leaving certs sit the 2012 syllabus, what do you do with that document? You throw it in the bin, because you have another one for 2013, okay? Which doesn't necessarily mean it's exactly the same as that, okay? So that's important for the teachers to realise, okay? Now, what's in the syllabus, okay? Well, you'll see here, there's an introduction to aims and objectives, then there's the syllabus overview, then there's the strands, okay? So, which is the pink pages in the middle, is, I suppose, the nuts and bolts and the meats of the part that you're actually going to be working with, okay? And also in the appendix is your common introductory course for your first years, and as well, there's the geometry course set out there for teachers, and a logical order in how you should teach it as well. And then the section C is the retained syllabus material. So it's your old blue book syllabus, basically, okay? So that's how you would make the link between the two. Now, you can clearly see there very little change from that to leaving certificate, except for what? Your trigonometric formulae has replaced the common introductory course. Okay, there's an appendix there, but other than that, the layout of the syllabus is exactly the same, okay? Now, this is a document that's on our website, and the idea behind it is, you can see here that there's different parts of, that's the syllabus taken, and there's different parts of the syllabus with circles around it or something underlined. Now, if it's underlined in blue, you can clearly see it comes from the student CD. If it has a red circle around it, that means there's a teaching and learning plan done out for that. And this document is live on the web. So if you go to that and click on it, it'll take you to that exact resource. Because you know the way at this stage, we have so many resources on the web, people will go, oh my God, where's it for this, that and the other. So if they go to that part of the syllabus on our website, it will actually take them to the website, okay? So the same idea there again. And now, there's your different things for something like probability. You have teaching and learning plans, student CDs, and handbooks, and they're all available on projectmaths.ie. And there's also student resources on ncca.ie/projectmaths. And there's also content courses, and at the moment they're looking at this exact stuff in the content course. Okay, patterns and that's on at night times in your obviously your local education centre. Okay. Now, and that's just some content from the nighttime courses. Okay. Now, and again here, just building up on some of your statistics. All that is available in the data handling cycle document. All that's available in the data handling cycle document and backed up with the students' CD. So if you go to the website, Teachers Strand 1 for senior cycle or Teachers Strand 2 senior cycle, you'll get the teacher handbooks here and the student CD. Now at this stage the student CD is actually yellow because it is all 5 strands. Okay, when this workshop was delivered initially, it was blue because it was only for strands 1 and 2. Does that make sense? And 1 and 2 only has, the blue CD only has strands 1 and 2, but the yellow CD has strands 1, 2, 5 on it. Okay. And there's the NCCA website. Again, they have all the syllabus and documentation there, and they're linked to student resources. Okay. And then just to show you some questions, there's the Leaving Cert Higher Level question in June 2010, and that was covered in Teaching and Learning Plan 10, and it was also covered on the students' CD. This here is Leaving Cert Ordinary level, and that was taken from, if you had looked at Teaching and Learning Plan 4 and Teaching and Learning Plan 1, your students would have been able to do that. Okay? Question like that was on the NCCA student resources. And again, this here is directly working with GeoStrips. Okay, and if your students haven't worked with this stuff, this is the idea. If your students haven't worked with this type of stuff in class, when they go answer a question, it's about something that never worked with before, obviously it makes it more difficult for them. Whereas if they're familiar with and seeing the things happening in their classroom, it's going to ring a bell. Does that make sense? Even something very simple there, like your odd and even this morning, you could do that now with an honours 5th year class when you're trying to introduce the idea of odd and even terms, and you'd have it done in a very short amount of time. But yet the idea will be far more ingrained in their head if you try and explain it up at the board. Okay? And again then, the last thing I'll show you is, there's a question based on census at school. And obviously we went through census at school with you in a previous workshop where they can put their data in online and get all the results back. And again, it's mentioning something that they should be familiar with from their school point of view. But of course the question can be tackled without having looked at it. But obviously, like everything, if you haven't seen it before, it's far more difficult for you to engage with the problem. Okay? So that's it for today, folks.